All right, guys, so this is part 5, work, power, and energy part of your study guide. And this is question 6. What 3 things are needed for work to be done? This one is, hopefully you all remember, but if you don't, it's okay. You need a force that causes a displacement. And I'm sorry, displacement. I didn't get that perfect, but here, let me put that again. Displacement. So you need a force that is applied, right? An applied force that causes some displacement in the same direction as the force. Okay, so force cause displacement are those 3 things. What is the law of conservation of energy? What does it say? Well, it says that energy cannot be created or destroyed. It can only transfer forms. Right, so we can start off with the gravitational potential energy. Maybe we're standing up somewhere, and then we come down. So our height is different, but our mass and our gravity is always the same. But that has now been transferred into another form of energy. Okay, kinetic energy or displaced energy, or we talked about kinetic energy. I'm not sorry, kinetic energy, but elastic potential energy. All right, so here's a work problem. It asks, how much work does Miss Brown do on a 21-kilogram bag of books that she lifts 10 meters straight up? So if you guys remember, our work equation is work is equal to force times displacement, and that's what we were just talking about the 3 things you need. You need, a force that causes displacement. But what I don't want you guys to forget, and this seems to be a very common problem, is that force is not always given in the problem. See here, it doesn't give us force. It just gives us a 21-kilogram bag. And if you guys remember from Newton's laws of motion, force is just mass times acceleration. So we have a mass. We have acceleration, it's gravity. And we have displacement. So we have a 21-kilogram bag. I'm going to leave the units out just because there's not a whole lot of space. We have a 21-kilogram bag. We're going to multiply it by the force of gravity, okay, so, or the acceleration due to gravity, 9.8. We're going to multiply that by the distance, and that is 10 meters. And then, put the units on the last one. And then we're going to just do the math. So it's 21 times 9.8 times 10, and the value I get is 2,058. And remember, the units for work are joules. Okay, so part A for number 8 is how much power does she generate by lifting the bag up if she does it in 3 seconds? I said generate twice here, sorry. So we have work is equal, or work over time is power. So if we have work, we solved it here in this part of the problem. We have 2,058 joules of work, and it's occurring over 3 seconds. So if we divide the 2, we come up with a value of, 686 watts. What? Watts. All right, that watts are the units for power. What is the bag's potential energy at the top of 10 meters? Well, it really should say gravitational potential energy, just to be specific. I think that I probably gave you guys this problem before we talked about elastic potential energy because we only were dealing with one, but we started dealing with 2, so you have to be more specific when you say potential energy. Okay, so how do we solve for gravitational potential energy? It's just mass times gravity times height. Now, if you're thinking, wow, that looks really similar to what we did up here, you are on the right track because we have a displacement here in the first problem, but here in B, we're asking about the height. Well, the height and the displacement are the same thing in this problem, okay? So our answer is going to end up being exactly the same thing as work. It's going to be 2,058 joules. And then you're probably wondering, wait, how come energy has the same units as work? Well, because work and energy are very much related, okay? So that's why they end up also with the same units. We didn't really get that much into it this time, but you'll end up seeing it in chemistry. Okay, so the next problem here is number 9, and it says, Gabby does an elegant dive off the high dive and had a kinetic energy of 12,000 joules just prior to hitting the pool. If her mass is 80 kilograms, then what is her velocity just as she hits the water? So we're going to set up our kinetic energy equation just so we know what it is. It's 1/2 mv squared. And then we're going to fill in this equation with what we are given in this problem. We're given 12,000 joules. We're given 80 kilograms. So we have 12,000 are equal to 0.5. That's just this 1/2, right? Put in decimal form. Times 80 kilograms multiplied by velocity squared. So if I take 0.5 and multiply it by 80, I end up with 40. And in order to get these onto the other side, I have to divide them out on both sides. So this was the 0.5 times 80 is 40. And that's all equal to velocity squared. So now our equation is set up to solve for velocity. So what are we going to do? We're just going to take the square root of 12,000 divided by 40, and then the square root of velocity squared. 12,000 divided by 40 ends up coming out to be 300. And don't forget you have to do square root. And so once you do the square root of that, your velocity is 17.32 meters per second. So her velocity just before she hits the water is 17.32 meters per second. So that is the value for velocity. What was the height that Gabby jumped from? So we have to set up a GPE equals KE equation, okay, and solve for the height. Well, remember, whatever you start with, you end up with, because energy is always conserved. So we can just say that KE is 12,000 because, we know that. GPE, or gravitational potential energy, is just M times G times H. So we know her mass. Her mass is 80. We know the gravity, it's 9.8, and we're trying to solve for height. So we have H on the left side, so we're going to leave it there. We're going to take 80 and multiply it by 9.8, and then we're going to bring it over onto this side. If I multiply these two, I end up with 784. So let me just rewrite this. Right? Ignore this little line. So I multiplied 80 and 9.8. Now I'm going to divide 784 on both sides. I end up getting these to equal to 1, so they cancel out. Let me just erase it so it's all pretty. Okay, so once I take 12,000 and divide it by 784, the value that I end up with is a height of 15.31 meters. There you go. Done and done. What was her height? That's how high up she was. All right. Question number 10. The Jacksons, not the musical group, the Jacksons decide to dare the scariest, tallest, most awesome roller coaster while on vacation. If the roller coaster was originally at rest at the top of a hill and reaches a speed of 16 meters per second at the bottom of the track, Assuming mechanical energy is conserved and all Jacksons began screaming at the very top of the hill, calculate the height of the track. So let's just pretend like this is the roller coaster or something like that. And their cart is up here to start. So at this point, we're going to calculate the GPE. And let's say it travels, and then down here at the lowest part, we're calculating the KE. So whatever energy is here at the top part will be the equal amount of energy that's down here at the bottom. So it does say that it is conserved. Of course, it's always conserved. That just means we're going to set up these two values to be equal to each other. So, we're going to then do what we just did in the last problem. Set them all up equal to each other, fill in what we know, and then solve for the variable that we'd like to know, and that is the height. So then we have mass, gravity, height. It's equal to 1/2 m mass velocity squared. So the first part of this problem is gravitational potential energy. The second part is kinetic energy. So we have a mass. Do we have a mass? Oh, well, I'm silly. These masses cancel out. M over m. You don't need the mass. Those cancel out. So then once those cancel out, we have G and H. It's equal to 1/2 V squared. So now what? Well, we're trying to solve for the H. So we divide the G on both sides. I know you're probably wondering, she hasn't put the numbers in yet. Well, sometimes it's just easier for me. I'm like all over the place sometimes. Sometimes I do it one way, sometimes I do another way. But there's always things that I always do. You always want to first show your equation. You always want to label your knowns and unknowns. And then you want to plug and chug and then box out your answer, okay? So our values are 16 meters per second, and that's all we're given. So we end up with an equation, and I'm just going to write this so we can see the words from the problem and what I'm doing. We end up with an equation of H, it's equal to velocity squared over 2 times G. Remember, this was 1/2, but the one up there is just 1 times velocity squared, so I got rid of it. Okay, so what are we given? We're giving the velocity. That's all we need because we know G. So we have this written out as 16 meters per second squared over 2 times 9.8 meters per second squared. That's a negative. So what do I end up with? Let me do my math. Hold on. 16 squared, 256. 2 times 9.8, and that's 19.6. Negative 19.6. So if I take 256 and I divide it by negative 19.6, I have a value of negative 13.06 meters. And that makes sense because you're coming down. So your height is a negative. If we're just going to call that coming down a positive, it would work out just fine. Okay, so that's your value. Their roller coaster started at a height of 13.06 meters. I'm going to stop there. We've almost gone 15 minutes. I know it seems like she just keeps doing 2 problems per video, but I just don't want your videos to be longer than that, and I think that YouTube doesn't let me do them longer anyway. So, all right, you guys, I hope this is really helpful, and if you have questions, email me. I'm going to stop this video, but then I'll continue on with the next one. All right, good luck.